So we're working out a few of these problems on the study guide. Number one, an integral is just another way of saying antiderivative. So we've seen it written a couple different ways. This is just the easiest way to write it. Because I don't have limits when I do the antiderivative, we'll have a plus c. We always try to rewrite before we do the antiderivative to make it as clean as possible. So 3 over x cubed, you could say 3x to the negative 3 plus 2x to the 3 halves minus 1. So we're going to go through. Coefficients stay. You add 1 to the power, so negative 3 plus 1 is negative 2, and you put the reciprocal in front, so that's a negative 1 half. Okay, so that 2 just stays. 3 halves plus 1 is 5 halves. Reciprocal in front, so that's a 2/5. Minus antiderivative of 1 is just x, and then we put the plus c on the end. So if you just simplify, you get negative 3 halves x to the negative 2 plus 4/5 x to the 5 halves minus x plus c. Might be useful to try a couple of these. How about number 7, the absolute value one? That's one that I know we've struggled with a little bit. So you have to rewrite it without an absolute value first. To do that, you take whatever's inside your absolute value, set it equal to 0. So we get x to be 3. So that's where we break up our interval. So we go from negative 1 to 3, and then from 3 to 5. If you go between negative 1 and 3, if I plug a negative 1 in here, 3 minus negative 1 is positive. So the absolute value isn't changing anything. If we put in something between 3 and 5, so if we put in a 5, 3 minus 5 is negative, so the absolute value does the opposite of that. So then we do our antiderivative of each. So the antiderivative of 3 is 3x minus antiderivative of x is 1/2 x squared. And we're evaluating from negative 1 to 3. This one, if you want to go ahead and distribute that, you can. So the antiderivative of negative 3 is negative 3x. Antiderivative of x is 1/2 x squared. And we're doing that one from 3 to 5. So if we plug in 3, 3 times 3 is 9, 3 squared is 9 times a half would be 9 halves. Minus, when you put in a negative 1, 3 times negative 1 is negative 3. Negative 1 squared is 1 times a half. Okay, put in the 5, so we get negative 15 plus 25 over 2. Minus, if we put in the 3, we get negative 9 plus 9 over 2. So we need to clean this up as much as possible. I'm showing my work just to kind of help prepare you for doing it without a calculator. Although my study guide questions aren't always nice. I try to make my test questions nice, but I don't always put a lot of effort into making pretty problems on here. So we would get 18 minus 9 is 9 plus 13. Let's see. What does this turn out to be? We get 10. So is that part okay? What about 8? Do you want to look at that one?
Yeah.
So we're going from 1 to 4. I'm going to go ahead and FOIL on top, so that would be 16 plus 8 radical x plus x over 2 radical x. So if we split this up, the first term, would be 16 over 2 radical x, or 2x to the 1/2. So 16 divided by 2 is 8, and we could write that as x to the -1/2 if we brought it up to the top. Next time you would have 8 radical x over 2 radical x, which is just a 4. Last term we have x over 2 radical x. So that square root of x is like x to the 1/2. So our coefficient is just a 1/2. X over x to the 1/2, if you subtract those exponents, you get 1/2. So antiderivative, add 1 to the power. So -1/2 plus 1 is 1/2. We have to multiply by the reciprocal, which is 2 times the 8 that was already there, so that would be a 16. Antiderivative of 4 would just be a 4x. And then with the 1/2, add 1 to the power, so 1/2 plus 2 over 2 would be 3 over 2. So you need the reciprocal in front, which is 2/3. So you have 1/2 times 2/3, which is just a 1/3. Because we have limits, we don't need the plus c. So we are just going to plug in each of these. So x to the 1/2 is just like a square root. The 3/2 is like the square root cubed. You put in 1, square root of 1 is 1, so that's 16 plus 4. 1 to the 3/2 is still 1. Square root of 4 is 2 times 16, we get 32, plus 16, 2 to the 3rd is 8. Those drop, 32 minus 4 is 28, plus 7/3. So if you're trying to do this on a test without a calculator, if you want to turn 28 into something over 3, you just multiply top and bottom by 3. So you get 84 over 3 plus 7 over 3, or 91 over 3. Any others on that first section you want to look at? What about the initial value problem? Okay. So it's just basically an antiderivative, but you have to find your constant at the end. 10 and 11, I know. Oh, really? I had a lot of people asking questions on those. So, okay, let's run through those. All right, so problem 10. I gave you the acceleration. And then I give you some information. The beginning position was 5, and the beginning velocity was 0. So that information is to find constants. So you really have to understand the difference, or the relationship between like position, velocity, and acceleration. So position is the first thing. The derivative of that is velocity, and the derivative of velocity is acceleration. So I'm asking you to get back to position, so we're going to have to do the antiderivative. So the antiderivative of acceleration would be velocity. So this would be t squared, 10 times a half is 5, minus 6t plus c. We need to go ahead and find c, so that's where we use this information. So it says if my time is 0, so if I plug in a 0 for all my t's, this whole thing equals 0. So we get c equals 0. So the actual velocity function is 5t squared minus 6t. Now we need position, so we have to do the antiderivative again. So this would be t cubed. So you need a 1/3 in front times our 5 is 5/3. minus, this would have to be a t squared, so 1/2 in front times 6 is 3, plus a constant. I'm going to use k just because I've already used c in this problem. So now, we need to find this constant. So here is the information we will use. My position at time 0 is 5. And it doesn't have to be 0 that I'm plugging in. I might say your position after 2 seconds is 5 or something like that. So I'm telling you what to plug in for your time. So if we solve that, we get k equals 5. So the actual position function let's go ahead and look at 11. So 11 and 12 really don't involve antiderivatives so much. Those were from that one day I was gone, and I had you guys watch that video. But they're really just going back to relating position, velocity, and acceleration. So just really several questions all testing the same thing if you understand how those pieces are related. So if we looked at that, an arrow shot vertically upward reaches a maximum height of 1,920. What's the initial velocity? So we have to find v sub 0. And I gave you the vertical motion equation. It tells us, first of all, that we start on the ground. So if we're on the ground, then our beginning height is 0. So we can plug in a 0 for that h. Then I can tell you about the maximum. So if you think about in the last chapter when we were graphing these things, anytime we want to find a maximum or a minimum, what do? Derivative. And that's when the derivative, we do the derivative and set it equal to 0. So if we set that equal to 0, we get that the initial velocity is 32t. So we're getting closer, but now we need to figure out what t is. So this is when we hit the maximum height. So I'm going to take that and plug it back into my height equation. And what is the maximum height? So at that instant, the height is 1920. So we have negative 16t squared plus 32t squared. So that's 16t squared equals 1920. Divide by 16. We get 120. So t is the square root of 120. So to get our velocity, we just have to plug that into our velocity that we found right here. So 32 times the square root of 120, which as a decimal is approximately 350.5. So really just manipulating those equations. We didn't have to do an antiderivative, we just had to use what we know about the relationship. Do you want to do number 12 too?
Will we have to memorize the equation?
No, if you had something with vertical motion, I would give you that equation. Anything else? Yeah, 12 is a lot like 11, so we can always come back to it if we have extra time. About 13.
13 I understand, but sometimes that's like more complicated.
Yeah, this one was definitely a complicated one. Okay, so for the sake of time, I'm not going to write all these down. But how many terms do we have here? 9. So that part tells me we're going to add up from I equals 1 to 9. So if it were 5 terms, it would be from 1 to 5. So what we have to do here, think about it. This is the first term, the second term, the third term, the fourth term. So these are the I values. So we need to come up with some equation using I to get these numbers. So we can see they're all the same in that they have a 1 over a square root. So we've got that much. We just have to figure out what goes into the square root. So this one, I agree, is difficult. Do you notice anything about these numbers? What are they really close to? Perfect squares. They're all 1 less than a perfect square. So we could think of it, it'll be something squared, but then we had to subtract 1 from it. Okay, so now we just have to think, this perfect square, that's 1 less than 4. So using my I, how can I get a 4? So we know 2 squared is 4. So if your I is 1, we would have to do, so then we check it and see if it works. So if I put in a 2, 2 plus 1 is 3, squared is 9, minus 1 is 8. If I put in a 3, 4 squared is 16, minus 1 is 15. 4 plus 1 is 5, squared, 25 minus 1 is 20. So we've got it. So that was definitely a harder one, but look for those patterns. You know, look for what they all have in common, like they all had a 1 on top, a square root on the bottom, and then try to figure out how to get there. Okay. Let's look at 15 and 16. You have to know these summation rules for the test. So remember, if you're adding up from 1 to n of I, that formula is n times n plus 1 over 2. If you're adding up I squared, it starts out the same, n times n plus 1 times 2n plus 1 over 6. And I cubed is just like the I formula if you square everything. So n squared, n plus 1 squared. 2 squared is 4. So you have to memorize these. So on 15 and 16, what I'm really wanting you to do is use the summation formulas. I didn't specifically state that, but on the test I would say, you know, use the summation formula. And a lot of these are a little more complicated to calculate, so I might say just set it up and you don't actually have to find the answer. So on 15, from 1 to 10, 3i squared plus 1. So we know coefficients stay. The I squared formula is n, my n is 10, times n plus 1, 10 plus 1 is 11, times 2n plus 1, so 21, over 6, plus, when you add up constants, you just have to take your constant times your n, so 1 times 10. And if you did calculate that, you get 1,160. So for the next one, my n is 5. So the I cubed formula is n times, or sorry, n squared times n plus 1 squared over 4, minus 3 times the I formula, so n times n plus 1 over 2. 2 is a constant, so you just take it times n, so 2 times 5, and that one gives you 190. Are those okay? Alright. So then the next question, 17, is like the long way of finding an antiderivative. So you can expect me to ask that on the test. Probably only do one of them that way because most of them, now that we know the shortcut, are going to do with the shortcut. But there will be one question like this, and there's a lot involved, so it scores a lot of points. Okay, so we have to find, first of all, the change in x and x sub I. So my change in x, we're on the interval 1 to 2. So 2 minus 1 over n, so 1 over n. X sub I is your starting point, so this interval started at 1, plus the change in x times I. So now we're going to do the limit as n approaches infinity of the sum from 1 to n of f of x sub I times the change in x. And since we do have that other shortcut way, I will expect all the work in how you got here. So you have to write it all out, you have to write the limit, you have to write the sum. So f of x sub I says I'm going to my function and I replace my x with this 1 plus 1 over n I times the change in x, which is 1 over n. So we keep our notation, keep carrying the limit and the sum. So now we have to multiply this all out. So this gives me 9 minus 4 minus 4 over n times I, all times 1 over n. So 9 minus 4 is 5 times 1 over n is 5 over n, minus 4 over n squared times I. So now when I do my summation rules, that's when the sum goes away. So I'm calculating this part. So we keep the limit. So I have 5 over n. I'm adding that up n times. So we take, it's just constant, so you just multiply it by n. Minus 4 over n squared, and then my I formula is n times n plus 1 over 2. So 5 over n times n is 5. We simplify this part, so we would have 4n squared, 4n over 2n squared. We're subtracting all of that off. So 4n squared over 2n squared is just 2. 4n over 2n squared is 2 over n. Then we can do the limit. Anything with an n on the bottom turns into 0. We get 5 minus 2, which is do we need to talk about 18, over and under?
No, this one's
Okay. Yep. Over and under is just left and right. Basically, you know from your curve which is which. You know, if I said, like, we were talking about a square root of x, then the left-hand sum, you would set up your rectangles like this. So would that be an over or an under approximation? Under. And then if you made your rectangles from the right, then they all fall above the curve, so that's your over. Or if you calculate both, the bigger numbers you're over and the smaller is your under. So on the back, we've got another one like I just worked for 17. So another one of the limits or the integrals, doing it the long way. Probably only be one on the test, but I put a couple on here. Do we need to practice that one?
I'm ready for time.
Okay, let's do it. Those are the harder ones and they're worth a lot of points. So this one, I gave it to you in integral notation to start with, which you know how to work it out, so you could always do that to double check your answer. But if I specifically state you have to do it the other way, then we need all that work. So the change in x would be 5 minus 0 over n, so 5 over n. X sub I is your beginning, plus 5 over n times I. So that's just 5 over n I. So we've got the limit as n goes to infinity with the sum from 1 to n. And we're replacing every one of our x's up here with this 5 over n I. So we have 2 times 5 over n I cubed minus 4 times 5 over n I squared plus 5 over n I plus 1. Okay, so 5 cubed is 125 times 2 is 250 over n cubed I cubed. 5 squared is 25 times 4 is 100 over n squared I squared. So now we're ready to do the sum. So 250 over n cubed would stay. The I cubed formula is n squared times n plus 1 squared over 4. 100 over n squared, then the I squared formula, n times n plus 1 times 2n plus 1 over 6. 5 over n, the I formula, n times n plus 1 over 2. Plus 1 is a constant, so it would just be 1 times n. So then we have to clean all this up. And we're looking for anything that cancels, so we could reduce an n squared here. So then 250 and 4, if I divide by 2, we get 125 over 2. If I FOIL that, that's n squared plus 2n plus 1. Here we could go ahead and cancel one of those n's. 100 divided by 6, we could reduce to 50 over 3. If I FOIL those two, here we can cancel an n. I missed something. What did I forget on here? I didn't multiply by my change in x. Remember, we always have to do the dx part, the change in x. I left that off. We did it here. We had that one over in. And the nice thing is I kind of caught my mistake because I knew right here if I plugged in infinity, that wasn't going to work. So I knew I'd left something off. Okay. Let's see. So if I multiply all of this out, I'm going to distribute my 5 over n at the same time as I break these up. So 5 times 125 is 625. N squared over 2n squared. So those n squareds cancel. Plus, okay, 625 times 2. Well, but then we're going to divide by 2n. So we can reduce that too. Okay. So in this term, those 2 n's would cancel. So we get 125 times 5. There's still an n on the bottom from this one. 125 times 5, 2n times n. Alright, this one, 50 times 2 times 5. N squared over n squared cancels. Minus 50. This one, the 3 n's would drop, so we get 250 over n minus 50 times 1 times 5 over 3n times n. 5n over 2 times 5 over n, so we get 25 over 2 plus 5 over 2 times 5 over n. And then n times 5 over n is 5. Alright. Are you okay with all those? So anything with an n on the bottom goes to 0, so we have a 625 over 2. Those will go to 0, minus the 500 over 3. Those go to 0, plus the 25 over 2. That goes to 0, plus 5. So, let's see, if we added this and this, that would be 650 over 2. 5 is like 10 over 2, so 660 divided by 2. So that's 990 over 3 minus 500 over 3, so we get 490 over 3. That one was definitely a little bit uglier. But just watch, like when you go to plug in infinity, you should have either constants or anything with an n on the bottom goes to 0. If you're left with an n like I was going to here, then you realize you left off something. 20 was just writing it as an integral, so it'd be the integral from -1 to 1. Those x sub i's just turn back into x's, so x squared plus 2x plus 1, and dx at the end. Do we need to talk about left, right, and midpoint?
Sure.
Okay. All right, so for the left, on any of these, we have to start out by finding our change in x. So it ends at 5, so it's ending minus beginning, divided by n, so 5 over 4, or 1.25. The left means you start with the leftmost point. When we find these areas, areas length times width. So the width is 1.25. Then we have to add up the 4 lengths. So our first point for the left would be a 0. So you plug it in for your x. So that's 0 cubed minus 1. Then you add your change next to get the next point. So 1.25 cubed minus 1. Add 1.25, so you get 2.5 cubed minus 1. Add 1.25, so 3.75 cubed minus 1. And then if you plug that in, you get that answer. Can you tell right now if this would be an over or an under?
It's over because you started at 0.
And it kind of depends on the shape of the graph. One way to check, when we do the right-hand sum, we're going to start with the rightmost point. So this started at 0, and my change in x is 1.25. So if we start with 1.25, you can ask yourself, which is bigger, 0 cubed minus 1 or 1.25 cubed minus 1? So if we're trying to decide, if I asked if this was over or under without actually working them both out, basically you can check. We know the right one would start out with the 1.25, and your first point would be the 1.25, right? Really all you need to do is figure out which of these is bigger, and the bigger one's over, and the smaller one is under. So this one's -1. This one, I don't know what it would be, but it would be positive. So this one's going to be bigger, so this one would be our over estimate, and this one would be our under. Just a quick check without working them all out. Okay, so we're adding up our 4 things. So we add our change in x, so 1.25 plus 1.25 is 2.5 cubed minus 1. 3.75 cubed minus 1. Add 1.25 again and we get 5. So really the only difference between these is the first and the last point. And if you plug all that in your calculator, you get here. Okay. the midpoint. So we start out the same way. The change in x is still 1.25. We have to add up our four things. So to get the first one, think about this starts at 0 and ends at 1.25. So I need the middle. What is halfway in between these?
625.
Okay, so that's the first thing I plug in. So we get 0.625 cubed minus 1. To get the next one, you still add 1.25. So that would be 1.875 cubed minus 1. Add 1.25, so we get 3.125 cubed minus 1. Add 1.25, so 4.375 cubed minus 1. And that one gives us 146, which is in between the other two, which it should be. Midpoint will always fall in between those. So I could ask for left and right, I could ask for over and under, and then midpoint is just the middle. All right. So I might ask you about an initial value problem. So when I say to solve this initial problem, I'm asking you to just find the original equation. dy dx, that's the derivative. So the actual function, you add 1 to the power. That's a 4, so we need a 1/4 in front. Derivative of the inside is just a 1, so we don't need anything else there. Then we always have the plus c. So now I need to find c, so I'm going to use this point to do that. It tells me that when I plug in a 2 for my x, this thing equals 1. So 2 minus 2 is 0. To the 4th power times the 4th is still 0, so my c is 1. So the original function would be this. So I did number 4. I have the integral of sine 2 pi x plus 2 dx. So this is inside my parentheses, so that's my angle. When you do the antiderivative of a trig function, when we do the derivative of a trig function, the angle doesn't change, so that stays. We have to ask ourselves, what has a derivative of sine? So the derivative of cosine is negative sine, so we'd have to have a negative cosine. Now if you did this derivative, you would have to do chain rule, so times the derivative of the inside. Derivative of the inside is 2 pi, so we need a 1/2 pi. And then a plus c, because we don't have limits. So we just have negative 1/2 pi cosine 2 pi x plus 2